Alright, you guys, if you guys could please turn to section 4.3, the graph of a rational function. I'm going to write in the steps that we're going to be following to analyze the graph of a rational function, and then we'll talk about it. Alright, depending on what textbook you use and depending on who you have as a teacher, there are many ways to quote-unquote analyze the graph of a rational function. For the sake of this assignment, these are the steps that we're going to be following. Initially, we're going to factor top and bottom, find the domain and range, and then if necessary, we're going to simplify the function and write it in lowest terms. We're going to locate all intercepts, test for symmetry, locate asymptotes, and then after all that, we'll graph it. So let's do an example. Okay, analyze the graph of this function. Okay, so first thing we're going to do is factor top and bottom. The top is already as factors as it's going to get. The bottom, however, is a difference of two squares. It factors to x plus 2, x minus 2. Okay? That's step 1. It's already in lowest terms. Locate x and y intercepts. Alright, the y-intercept is when x equals 0. If I plug in 0 for x, I'm going to get negative 1 on top and 2 times negative 2 on the bottom. Negative 1 over negative 4 equals positive 1/4. So the y-intercept is 0, 1/4. Okay? Now, to solve for the x-intercepts, I'm going to set this equal to 0. So I've got x minus 1 over x plus 2 over x minus 2. This all equals 0. If I multiply both sides by x plus 2, x minus 2, this cancels out, and I've got x minus 1, and this just is still 0. I add 1 to both sides, x equals 1. So my x-intercept is 1, 0. Alright, so this was part A. B, there wasn't really anything to do. This is part C. The next step, where's my cursor? There it is. Okay, test for symmetry. Now, we actually learned this a little while ago. In order to test for symmetry, you're going to plug in negative x. So let's move this down here. Actually, see if I can fit it up here. I think we can do this up here. Okay. So if I were to plug in negative x, I'm going to get negative x minus 1 on top. And I'm going to use this equation. Negative x squared minus 4. This becomes just regular x. Okay, this is not the same as the original function, so it's not an even function. Alright, now let's multiply everything by negative 1. If we multiply the top by negative 1, we get negative x plus 1. The bottom stays the same. This is not the same as this either, so it's not odd. So it's not even, not odd, no symmetry. Alright, so that's part D. Next step is to locate vertical asymptotes, and then we're going to locate horizontal and vertical asymptotes, or horizontal and oblique asymptotes. Okay, the vertical asymptotes, hopefully you guys remember, are actually pretty easy. What was this? Was this F? No, it's E. Okay. We're just going to set the bottom equal to 0. X obviously equals 2 and negative 2. So these are our vertical asymptotes. Alright, horizontal asymptotes. If you look here, the power of the bottom is bigger than the power of the top. So, automatically, there's a horizontal asymptote at y equals 0. Okay. Let's graph it. When you graph this, let me put the asymptotes in a different color. There's a horizontal asymptote at y equals 0. There are vertical asymptotes at positive 2 and -2. There's no symmetry. Let's go with green for the actual graph. 0, 1/4, where's my cursor? There it is the y asymptote, so it's like here. Come on, there it is. Okay, so there's that, and the x-intercept, I believe, was 1. Okay. Alright, now you all have graphing calculators, so I'll just let you guys go ahead and graph this. And let me pause it here and draw. Alright, I actually want to show you guys this. Sometimes when you graph something that has asymptotes, it actually draws the asymptotes in there. As you can see, it kind of goes and then like very jagged. That's actually not what the graph looks like. This is just a flaw in the calculator. The graph should look something like this. Let's see if I can draw this correctly. So it goes like that, and like that. Let me pull this up again so you guys can compare. Alright, so my goal for you guys, because graphing calculators are never going to be completely perfect, I want you guys to be able to look at this and recognize that it's really supposed to look like that. It turned off. Okay? So, you know where the asymptotes are. Just ignore the asymptotes should they appear on the calculator. Alright, I'll let you guys try that one. Let's take a look at this one. Okay, analyze the graph of this rational function. Alright, first things first, let's factor the top and bottom. The top is x plus 1, x minus 1, because it's a difference of 2 squares. Okay, no simplifying to be done. The x and y intercepts. Let's see here. Come on, where's my cursor? Okay, if you were to plug in 0 for x, hopefully you guys can see that you would get a 0 on the bottom. R of 0 would give you 0 squared minus 1, and you get a 0 on the bottom. You can't have a 0 on the bottom, so there's no x-intercept. Okay? Now, if you set this equal to 0, the bottom just cancels out. So we have x plus 1, x minus 1. Oops. So x equals positive negative 1. Oops, I messed up. Sorry. There's no y-intercept. There are x-intercepts. There we go. My bad. There are 2 x-intercepts. 1, 0, and negative 1, 0. Okay. Alright, part D. What was part D? Was it symmetry? Give me a sec. Part D, yes, symmetry. Alright. You might be able to do this in your head, or you'll hopefully get to the point where you can do part of this in your head. If you were to plug in a negative x, where's my cursor? There it is. You're going to get an x squared on top, because the negative just cancels out, but you're going to get a negative x on the bottom. Okay? That's not going to work, so it's not even. Okay? If you make the whole thing negative, however, whether you put the negative on top or put the negative on bottom, it's the same thing. This is essentially the same thing as this, except that I multiply the negative into the top here and into the bottom here. So it actually is odd. So it's symmetric with respect to the origin. Okay, now let's look for asymptotes. We already figured out there's an asymptote at 0, because when the bottom equals 0, x equals 0. Vertical asymptote, x equals 0. The horizontal asymptotes, the top is 1 more than the bottom. Okay? Now, hopefully you guys remember that that means there is an oblique asymptote. I'm going to divide x into x squared, x squared minus 1. In order to get x squared, I have to multiply this by x. Pull down the negative 1, can't really put anything in there. So it's going to be x minus 1 over x. Okay, and this goes to 0. So the oblique asymptote is y equals x. Alright, now let's graph it. Make the asymptotes a different color. Okay, we already know that there is an asymptote at x equals 0, vertical asymptote. There's an oblique asymptote at y equals x, which is a line kind of like that. Actually, let me change colors again. Let's go to purple or something. X-intercepts at 1 and negative 1. Okay? Alright, let's take out our calculators and graph this. Alright, so y equals x squared minus 1 over x. Graph it. Looks something like that. Okay? So I'll graph that here. Kind of, sort of. Something like that. Looks much better on the calculator. And as you can see, it is actually symmetrical about the origin. Alright, I'm going to leave it at that for this video. We'll go over example 3 in the next video.